Hi everyone, Mary here, and we're going to do an open pipe example problem. So here goes. An open organ pipe is 0.77700 meters long. It is vibrating with a frequency of its second overtone. If the speed of sound in air on this day is 343 meters per second, what is the frequency of the note produced? All right, so we've got a open pipe, and this open pipe is in its second overtone. Now we've got to kind of go back and look at our open pipes. So let's kind of build this up a little at a time. For our open pipes, its fundamental mode of vibration is going to be half wavelength, and it's going to have an antinote at each end. Its first overtone is going to look like this, and that's going to be the first overtone, and that's going to be 2 half wavelengths. And the second overtone is going to look kind of like a bikini top, and that's going to be 3 half wavelengths. Now, why do we need this picture? We need this picture in our heads and mathematically because we now know that the 0.700 meters is equivalent to 3 half wavelengths. So we can calculate the physical wavelength of one of these waves. The wavelength of one of these sound waves is going to be equivalent to, and I'm now just setting this up so that this is my equation, the wavelength is going to be 2 times 0.700 meters divided by 3. So the wavelength of my wave is physically going to be, when I do the math, 0.47 meters. So we have to have our understanding of our overtones and how the pipes oscillate in order to often calculate our wavelength. So there's my wavelength. I want to know what the frequency is. Frequency is my question mark. And we're told that on this day, the velocity of sound is 343 meters per second. Well, we look at our list of formulas. Our equation is velocity is frequency times wavelength. So do a little algebra. We're going to solve for frequency. Frequency, to get that alone, we're going to divide both sides by wavelength. So frequency is going to be equal to velocity divided by wavelength, 343. Wavelength is 0.47 meters. And when I do the math, I end up with 730 hertz. Now, hertz is the unit we should have here. Where does hertz pop out of this mess? I have meters per second divided by meters. If you remember messing around with fractions, when you divide the fraction, invert and multiply. So this is times 1 over meters. Meters cancels. I have 1 over seconds, and 1 per second is a hertz. So that is an open pipe problem. We're going to come back next and do a closed pipe problem. See you then.